So hello everyone, welcome. My name is Gaetan Karst. I'm 26-year-old and I come from France. For my tech talk, I wanted to talk about the goal behind programming languages evolution and emphasizing on the why of this evolution. So after a very short introduction, we're gonna have an overview of modern programming history. Then we're gonna see the main factor of evolution, which is abstraction. And we're going to have a very short demonstration about a very core concept of abstraction. Then we're going to finish on seeing the role of the new technologies in this evolution. So you may not know this lady. Her name is Ada Lovelace. And in 1842, she invented the first algorithm intended to be run by a machine. In 1842, what kind of machine could run an algorithm, right? Well, this is this machine. This machine is called the analytical engine, invented by Charles Babbage. And as odd as it may sound, it is actually a computer. Well, more precisely, it's a mechanical computer designed to perform very complex logarithmic and arithmetic operations. Coming back to the algorithm I was mentioning, so this is how the algorithm looks. It is designed to compute the recursive case of the Bernoulli number. So for those who don't know what the Bernoulli number is, it's actually the same principle as the Fibonacci number that we all learn when we first learn programming, and especially when we first learn JavaScript. So in this algorithm, you can see a table representing intermediary computation stage. So basically everything that you can think of that can compose an algorithm, whether it is variable, loops, etc. It is included in this very table, in this algorithm. And this is actually the very first execution trace that we have in the history. Execution trace, which is a very important core concept in programming. So let's have an overview of modern programming history. So here we have a timeline of all the programming languages from 1940 to nowadays. Of course, it would be pointless to go through all those dates, all those languages. But as a programmer, I think that there is actually one date that we should all have in mind, keep in mind actually. And this is 1972 and the birth of C. Why the birth of C, you would tell me? Well, because in the programming sphere, C is widely considered as the father of all modern programming languages. Why so? Because with the emergence of C, there is a lot of features that we still use nowadays that have been included in the language, whether it is conditional statements, loops, and all those features that we use daily when we code. Those features have been implemented in the language so that the language can be more human-friendly, more human-readable. But if it's more human-friendly, it also means that it's more machine-unfriendly. The machine have more struggle to understand it. And this is why C needs a compiler. But what is a compiler? Well, a compiler is just a program that translates high-level language into a lower-level language, understandable by the machine. In the case of C, the C code is going to enter the compiler, and the output of the compiler is going to be machine code, the native code of the machine, which is binary language. But does every languages need a compiler? Well, no. As you may know, JavaScript, Perl, Python, basically all scripting languages don't need a compiler. They actually need an interpreter. So now, what is the difference between those two, like a compiler and an interpreter? Well, with a compiler, let's say that you have a C program that is actually 2,000 lines of code. Well, the compiler is gonna, every time that you're gonna run your code, the compiler is gonna go read your C program top to bottom, and all the time is gonna do that. He's gonna read the whole program and then translate it to machine code. While with an interpreter, the interpreter is gonna read and translate your code line by line and change by change, which is a huge gain of efficiency and of speed that we actually need in some languages such as JavaScript that are web-based. With the evolution of programming languages, we saw some generations appear from first generation to fourth and even fifth generation with AI and machine learning. The first generation is considered as machine code. It's very low level, and programmers only deal with binary number. Here is an example of a very simple hello world program in binary code. So as you can see, there is only 0 and 1. It's really hard to understand for a human, but it is the native language of the machine. This is what the machine understands. Then we have the second generation, which is assembly language. It's also low level and converted into machine language using an assembler. An assembler is quite similar to a compiler. And here is an example of still a simple hello world program in assembly language. As you can see, for just printing a hello world, there is a lot of line. It's not clear what the code does. And it's actually not quite logic for a human. And then we have the third generation languages. Those are high-level languages, and the third generation language, third generation is composed of languages such as Fortran, C, C++, but also JavaScript, Python, Kotlin, all those languages that allow the developer to focus on the logic without taking care of the internal architecture of the system. All those languages, they are in the third generation. Here is a very simple Java program that will print hello world, but whether you use Python or JavaScript or any other language, is going to be the same principle. To print a hello world, you're just going to make a function and print a string hello world in your console, right? But we saw that behind this simple hello world, there is actually a lot of logic with assembly language and binary code. There's a lot of logic that are abstracted from the programmer. And then we have the fourth generation. They are very high level languages. They have then a higher level of abstraction. And this generation is mostly composed of database support language, mathematical optimization language, and GUI development language. Some languages of the fourth generation, for example, SQL, that we all know, MATLAB, R, all those languages that have a specific goal to compute is the fourth generation languages. So now let's see the main factor of evolution, abstraction, which is like one of the core concepts in programming languages. What is abstraction, right? So abstraction is one of the key concepts of object-oriented programming languages. Its main goal is to handle complexity by hiding unnecessary detail from the user. And this is a very important definition. But the thing is, the next part of the definition is actually also super important. That's a very generic concept that's not limited to object-oriented programming. And indeed, abstraction is not only limited to one paradigm. It applies in programming languages as a whole. But how abstraction takes place in programming? Well, as we saw, there is new paradigms. We can mention procedural programming with C, but also object-oriented programming, functional programming. All those paradigms are layering a layer of abstraction from the logic to the programmer. Then we have garbage collection. And for me, garbage collection, in my opinion, is actually the most core concept of abstraction. But what is garbage collection? Well, at the time when you needed to code in C or C++, if you wanted to use a variable in your program, you needed to allocate manually memory for it. And when you no longer needed this variable, you needed still manually to deallocate this memory so that the variable does not appear in the memory again. Why you needed to do that at the time? Well, because at the time, memory was a scarce resource. They didn't have the machine that we have nowadays that have unlimited memory. And this is why actually nowadays, with the increasingly power of our machines, it actually doesn't make sense to save this memory. We can just let the language handle the memory, manage the memory for us. And in a lot of cases, actually, the language does it even better than a human. And this is what garbage collection is. It's just going to be the role of the language to manage the memory, and it's not going to be the role of the programmer anymore. Then we have loops. as I said a little bit earlier, loops were not a thing in primitive programming languages prior to C. They have been introduced in order to make the language more human-friendly. Then we have higher order function. We all know what a higher order function means at Code Chrysalis because we learned it, right? You all know for each, map, filter, reduce, all those functions that someone else coded for us so that we can use them in our program without taking care of the implementation logic behind those functions. And I'm going to give you a very short demo about this concept. Then we have libraries. Libraries, we can mention some language such as Java that have a huge amount of libraries in which the programmers can pick method from. And those methods are actually also a layer of abstraction that hide the logic, a piece of logic from the programmer. And then we have data type definition. For me, that is the second most important core concept in programming languages. What is data type definition? Well, data type definition is the difference between statically typed languages and dynamically typed languages. In static typing, it is the role of the programmer to explicitly define the data type of a variable. If it's a string, the programmer needs to tell the compiler that, yes, this variable is a string. If it's an integer, you need to tell the compiler that it is an integer, etc., etc. And most importantly, variable cannot change type and are not interchangeable, meaning that if you have a 2, the number 2, that is of type integer and the number 2 that is of type string, you cannot add them up. You cannot minus them. This is not something that you can do in dynamic typing, in statically typing, sorry. But in dynamic typing, it is the opposite actually. In dynamic typing, data type are defined by the language at runtime, meaning that it's no longer the role of the programmer to tell the compiler the data type of the variable. And more importantly, variable can change type. And this is super powerful, meaning that in the same example, if you have a 2 integer, and if you have a 2 that is a string, you can, in dynamic typing, in dynamically type languages, you can add both, because the compiler is gonna translate the string into an integer, because the integer is the data type that make more sense in this context. So let's jump on a very short demo of how higher order function can make us save time and save energy. So in C, let's say that in my program, I need to sort an array. So in C, if I want to sort an array, I will first register the function on line 5. I will just tell the compiler, okay, so below the main function, there is a function called selection sort. And this function is going to take an array that is unsorted. In the main function, which is actually the block that is read by the compiler, I'm just going to define an array, unsorted array, and execute my function selection sort that is below the main block. This selection sort, sorry, is composed of 2 blocks: an iterating logic that will take care of iterating through each element of the array, and a swap logic that will take care of the actual sorting logic. Well, as you can see, we can't really know what's happening at first sight, right? It's actually quite complicated. And even me, like to code this selection sort in C, I needed to make some research on the internet. Like, okay, so how do I sort something in C again? Oh, okay, yeah, but like, do I need to use pointer? All those kind of stuff. This complexity is not hidden from the programmer. Now let's do the same, but in JavaScript on the right side of the screen. So if I want to sort the very same array, I'll just, in JavaScript, I'll just make a function. I will call it this function, sort is easy. And this function is actually going to take in as an argument, is going to take an array. And now we're almost done, actually. I just have to return the array that my function takes as an argument. And I need to call the sort higher order function that is available in the standard JavaScript library that is made available to all programmers in the standard library of JavaScript. And boom, actually, my function is already sorted. If you want to see the array sorted, let's call the function. And we're going to pass in the initial array that you see on line 1. And let's run the code now. Boom. 1, 2, 3, 4, 5, 6, 7, 8, and 9. My array is sorted. And this is how powerful higher order functions are. They make you don't have to go on the internet, search, okay, so how do I sort that? You don't have to make any research. It saves you time and energy. So now, after this very brief demo, let's see what is the role of the new technologies in the evolution of programming languages. So the internet era just skyrocketed the evolution of programming languages, and I really mean that. Why? Because with the internet, programmers' need changed, actually. We saw the apparition of some concept such as functional programming. Functional programming, which is a function, a concept that is relying heavily on giving the most productivity to the programmer. So much that in programming actually become increasingly more consumerized. When Facebook was conceiving React, for example, the React language, they had to design it so that it's easy to learn, easy to use, and that can be a language that can be widely used over the web. But also, if they design this language, it's because they want their developer to develop with this language. Why? Well, because they think that if Facebook developers develop in React, of course, they will be more productive. If those developers are more productive, it means also that there is more money coming in. And this is how it's increasingly more consumerized, because we consume more and more programming as a product. And this is actually okay, because it allows us to have more easier language to learn and easier language to use, which is actually nowadays our need. And this is actually where we see the separation between computer engineers and computer scientists. Computer engineers will need the speed that a C language or a C++ language can offer them, because they need to code on hardwares, which is way better with languages that have a very low level of abstraction, as we saw. But well, with computer science, computer scientists, since the start of the internet, our need changed, and we don't actually really need this speed. Computer scientists will prefer to have a language like the productivity that a language like Python or JavaScript can offer them, because they need to first be faster when they code and be more productive. Last thing I want to talk about is mobile devices, because since the apparition of my mobile devices, programmers had to adapt to different internal architecture that those devices provided. Also, we are increasingly more using our phone, so much that we saw, for the past 10 years, we saw a democratization of services on mobile platforms such as Uber, Google, Microsoft, and all stuff like that. They all have their app. All those big companies, and now even medium and small companies, for them, it's super important, and it's even mandatory to have a presence on mobile phone. So much that actually now we saw some languages optimized for those specific platforms, such as Kotlin, which is the improved version of Java for Android, and Swift, that is the language used on iOS nowadays, that is supposed to replace Objective-C. In conclusion to this tech talk, we saw that there is actually few factors that can explain this evolution. First, primitive languages are actually quite complex. Our need changed. And we now need to emphasize, like for computer scientists, we need to emphasize more on the productivity that a Python or a JavaScript will give us, rather than on the speed than a C or a C++ will give. The new technologies, because there is more and more new technologies, new devices that actually programmers need to develop on and adapt. So this creates increasingly more new languages. The money, because this is actually one of the big factors. Someone that is coding in C and someone that is coding actually the same program in Python, the difference will be just 2,000 lines of code. Meaning that depending on why you want to code, like what is the goal behind you want to achieve with the program. Programming with Python language, for example, will always be more productive because you will have to spend less time code and more time on developing new features, etc., which means at the end, more money for companies. And lastly, communities. We can mention some languages such as C, Java, JavaScript, that are 3 languages that have huge community that carry them along the programming sphere. Well, the word of the end is that I want to remind yourself that technology keeps evolving, keeps advancing, and you need to keep yourself updated on the latest technologies. Thank you for listening to me. Keep coding, and you can follow me on GitHub at Gaetan Karst. Thank you very much for your attention.